Section 4, Unit 3, Drill Press Operations. Introduction. Workpiece can be set up and machined after familiarity with drill press safety, selecting proper tooling and work holding speeds and feeds. General drill press safety. Become familiar with general drill press safety precautions. Become familiar with specific caution statements throughout Unit 3. Speeds and feeds. Speed, RPM factors, tool material, material being machined, tool type, and tool diameter. Feed, movement of cutting tool into material, and machinability of material. A machinability ratio chart tells how easy or difficult it is to be machining a given material. Cutting speed, distance a point on tool edge travels per minute, and feed rate in inches per revolution or feet per revolution, distance advanced per revolution. Alright, cutting speed is the distance a point on a cutting edge circumference of a rotating cutting tool will travel in 1 minute. An example of a chart showing recommended cutting speeds for drilling and reaming operations for some carbon steel using high-speed steel cutting tools. Calculating spindle RPM. RPM equals 3.82 times CS, which is the cutting speed in surface feet per minute, over D, which is your diameter of the cutting tool. The cutting tool advances 0.003 or 3 thou per revolution. The cutting tool is advanced into the workpiece at a rate of 3 thou per revolution. A chart provides guidelines for appropriate twist drill feeding rates. Locating holes on a drill press. Layout, accurate tool to tolerances. Scribe visual reference. Secure workpiece. Methods for aligning center finder or wiggler. Pointed edge finder or center drill. A vise positioned on a table so that if the clamps were to fail, the vise would hit the column instead of the operator. So you would always want it on the left side so it would hit the column. The center finder set with its various attachments. The pointed probe is normally used for establishing a hole location on the drill press. A pencil being used to true the center finder to use. Prior to clamping the vise to the table, the work is positioned by aligning the center finder point with a punch mark. This is a cone pointed edge finder. Prior to clamping the vise to the table, the work is positioned by aligning the pointed edge finder point to the punch mark. Center drilling and spot drilling. Center drill or spot drill creates positive start for twist drills. Spot about 1/2 the depth of the point of the twist drill, set up with depth stop. A chart shows the dimensions of a standard center drills with their sizes and diameters. 90-degree included angle tip on a 1/2 inch drill diameter, and then 118 is 0.3 times the drill diameter. And 135 is 207 times the drill diameter. And that will give you the tip length. Drill tip length can be estimated by using the formula. A hole being spotted with a center drill. Drilling, select and mount drill. Pilot holes prepared for large diameter holes over a 1/2 inch. Set speed and manually feed drill to check position. Through holes versus blind holes. Set depth stop if it's a blind hole. A pilot hole is drilled to a diameter slightly larger than the width of the larger drill's dead center. Steps can be taken using a chisel to pull a drill point back to center. The drill has started off location on A, so B, make a small mark with a chisel along the cone in the direction of the hole needs to be moved. And then C, the lips of the drill will be pulled back by the chisel mark and bring the drill into proper location. drilled hole depth is measured to the depth of the full diameter, not the tip. A blind hole is dimensioned to the full diameter depth, not the depth to its point. First, drill into the work to its full diameter with the quill against the depth stop. Then adjust the depth stop so you can have your desired full diameter depth. Another method of setting the depth stop requires touching the drill tip on a spacer of known thickness on a work surface when the quill is against the depth stop, and then use adjusting the stop to the desired full diameter depth plus the drill tip length of the spacer thickness. A gauge pen can be used to check the full diameter depth of hole. You just slide it down till it touches and then measure from the top down there. Then you will subtract the overall length of the pen from what dimension you get. Reaming slightly enlarges hole to more accurate sizes and finish than producing by drilling. So drill 10 thou undersize for a hole up to 1/4 inch. Drill 15 thou for a hole between 1/4 and 1/2 inch, and drill 25 thou for a hole between 1/2 and 1.5 inches. So 10 thou small for 1/4, 15 thou smaller for 1/4 to 1/2, and 25 thou smaller between 1/2 and 1.5. When possible, ream the hole without moving the workpiece after drilling. Speeds are about 50% to 60% of those used for drilling. A reamer should have a small amount of clearance in the bottom of a drilled hole so it doesn't bottom out. Counterboring and spot facing. When possible, perform these tasks after drilling without moving the workpiece. If the workpiece has been moved, the pilot can be used for alignment. Pilot 3 to 5 thou smaller than the hole. Speeds are about 50 to 60% of those used for drilling, and use the depth stop. The pilot of the counterbore is used to check alignment with the hole. When the pilot slips into the hole without binding or flexing the counterbore tool, tighten the clamps. A. Adjust the depth stop in small increments until the counterbore lightly touches the surface of the work, and then B. Then the depth stop can be adjusted to the counterbore to the desired depth. Chamfering and countersinking. Countersinking/chamfering on existing holes. Clamping to table unnecessary. Use a block to keep the vise from rotating. After touching the tool against the top edge of the hole, determine the feed amount. D is the desired diameter, or capital D is the desired diameter, and lowercase d is the existing hole diameter. So calculating depth for a desired countersink diameter. So it does change between a 60 degree and 100 degree. A countersinking operation and proper position of a table stop to prevent vise movement. Tapping. Tapping with a drill press keeps tap aligned vertically. No need to check for alignment using a square or block. Clamp work securely. Rotate tap by hand using tap handle/wrench. A center point can be used to realign for tapping. Clamp securely after aligning. A hole to be tapped can be realigned with the spindle by bringing a spindle-mounted center point inside a hole and against the work. The vise floats into position and is then clamped securely to the table before tapping. A spring-loaded tap center maintains alignment and applies pressure downward when starting a tap. A solid tap center is used to maintain alignment. When starting a tap, the quill pressure is applied with one hand to help the tap engage while turning the tap wrench with the other hand. Estimating tap turns for thread depth. So inch thread is turns equals depth times TPI, which is thread per inch. So a tap with a 3/8 16 to 5/8 depth, the depth is 5/8, threads per inch is 16, so 5/8 times 16 is 10. 10 turns are needed. And a metric thread, turns equals depth times pitch, or divided by pitch. Tap is M8 by 1.25 to 12 millimeters deep. The depth is 12, the pitch is 1.25, so 12 divided by 1.25 is 9.6. Just over 9.5 turns are needed. The usable depth of a thread is checked by using a screw. The screw is turned into the hole unit until it bottoms. The protruding length is measured and is subtracted from the overall screw length. A reversible tapping head is used to advance and retract tappings using machine power. It has a clutch built in so it won't let it go too deep